All right, welcome into the new video. I'm very excited, so excited. I've been grinding on this video. This is my third try. Hopefully it will go well. Okay, so what we're doing here today is we're performing a linear regression analysis. We're gonna do it for two types of data, one that I made up and one that is actually real data that could probably have a chance to help people actually, which is the California wildfire data. Let's start by practicing a little bit with some of the made up data. So if you look at the top of the linear fires document, you'll see this data table right here, number of followers and average number of likes on the last 5 pictures. So this is data that I made up that could potentially represent a selection of Instagram users, right? And you can see that as the number of followers increases, so also does the number of likes, right? Which kind of makes sense. Okay. So here we go. Let's analyze the data. Let's grab it. Let's do a Control or Command C and come over to our worksheet here. Actually, before I paste it in, I'm going to select everything and just increase the size a little bit so that it's easier to see on the video. If you want to do that, you can. If you don't want to, you don't have to. All right, we'll expand column B a little bit. Okay, so there we go. We've copied our data and this looks good. Let's make a graph out of the data by selecting all the data by dragging over it. And so we'll drag over it, select the data, go to the insert menu and put in a chart. Okay, and there comes our chart right here. It puts number of followers on the horizontal x-axis, which is where we want it. It puts average number of likes on last 5 pictures on the y-axis, also where we want it. And it made us this nice bar graph, which is not what we want. So we're going to come over here to chart type and we're going to scroll down to scatter plot and we're going to choose that one. Now each of those bars turned into points. So we have now our 11 data points are graphed for us right here. Now what linear regression means is we're going to try to find a line that sort of goes through the center of all those data points. Now, some of the data points are going to be a little too high, some are going to be a little too low, some are going to be right on there, but we're going to try to find sort of the best approximation of a line that we can. The way we're going to do that is go over to Customize, click on the Series drawer and open that up. And now within the Series drawer, we're going to check this box right here that says Trend Line. And we can do some other things. We could try the data labels. You can see what that does. You can try the error bars, see what that does. But we're going to check the trend line box. We can change the color if we want. We can change the opacity. Can have some fun playing around with it a little bit. And then we're going to come here to the label. Now the label, we want to use equation. And we want to click right here to see the show r squared. Now you can see right here, r squared equals 0.974. Okay, so we've created our chart. That's perfect. Let's come over here to our worksheet and right where it says Insert Graph, be sure to apply chart and axis titles. We'll click right below it here and we'll click on the Insert button. We'll insert a chart from Sheets. Take that one, click on it and click Import. All right, there it is. And now luckily it actually did it did the titles of the graph and the titles of the axis for us. One cool thing about this is it's linked. So if I come over here and I want to change something, like let's say I find this title to be a bit clunky and I want to change it, I can click on that and I can say linear regression and we'll capitalize likes. And then we'll put the linear regression in the title. And that should update right here for us. Oh, right here it gives us that button we can click and it's updated. Very nice. Okay, so we've got this graph is now linked to this worksheet. If we change the data for whatever reason or we change anything here, it will then give us that update option right here. So that's wonderful. Okay, moving on, let's answer some questions about this. the first question says, what is the equation of the trend line f of n equals L, where n is the number of followers and L is the number of likes? So here we go. We can see the equation 0.102x plus 61.9. Okay, so let's see if we can remember that. Let's see. 0.102x, and maybe we'll use some parentheses here, plus what was it, 67.9. Oops, 67.9. Okay, believe that is correct. 61.9. Okay, I was wrong. All right, 61.9. Okay, there we've got the equation copied down accurately. Now we're going to format this equation so we can talk about it a little more easily. So let's go here, and we're putting this in the form f of n equals L, right? So our variable is going to become from an x to an n for number of followers and L for likes. So we're going to put L in first. Number of likes equals 0.102 parentheses n plus 61.9. All right, very good. Very good indeed. There is our equation that we can use to make predictions. Okay, and now right here, question 2 asks us to make a prediction using that equation. It says, if an account similar to these has 1,150 followers, how many likes do you think they will have on average? Okay, so let's do this calculation and see. This equation right here comes from the chart, right? So that's the equation of this purple line right here. So we're looking right here about 1,150 followers. So I'm expecting this to be around like 175 or 180, somewhere in there. Let's do the math and figure it out. So L equals 0.102. Now in this case, N is 1,150 and plus 61.9. Okay, wonderful. Now let's do that multiplication. 0.102 times 1,150. I actually did this already. Here it is, 117.3. So L equals 117.3 plus 61.9. Okay, now we'll do some mental math here. Always a little risky, but let's see. I've been doing this video so many times I should have it memorized by now. I think it's 179.2. Does that make sense? I think so. That's getting past the quality control. So there we go. We would expect likes to be 179.2. Maybe we could round that to 179. Why not? And that does seem to make sense, right? Remember earlier looking at the line, I had predicted that it would be about 175 or 180, and there it is, 179. Okay, number 3, very similar. Number 4, also similar, except this time we know the L value. We know the number of likes. We're trying to solve and figure out what N is. Okay, so there we go. Okay, now here we get into some more interesting questions, like what is the R value? What does this mean about the data? What is the independent variable? What is the dependent variable? What is the slope of the trend line? Domains and ranges. Also some other things that might have a linear relationship. Okay, so those are some questions that we're going to need to take a little time out from actually doing the work, and we're going to need to look at a presentation I made and explain a little bit of this. If you already know this, you can feel free to skip through. Maybe I'll try to throw a timestamp on there. But anyways, if we need to know about it, let's get into it here. All right, so here is the presentation I made. We're going to first talk about linear relationships. Now, linear relationships relate two quantities, x and y. X is known as the independent variable, also known as the predictor or explanatory variable, and y is known as the dependent variable, also the response or outcome variable. Okay, so let's look at an example here. We saw an example here. Here's another one that I found on Google. This is a linear regression right here, comparing rainfall in millimeters to umbrellas sold, right? So the independent variable is the rainfall. That's the one that is the predictor or the explanatory variable, right? Because it explains when it rains, right? When the rain increases, people buy umbrellas, right? So the rainfall explains the umbrellas in some type of way, right? So as rainfall increases, umbrella sales also increase, right? So that's this first relationship right here. As X increases, Y increases. Let's look at another one where as X increases, Y decreases. This was a funny one. I also found this one on Google. This one is comparing my sleep to my grumpiness. The more sleep I get, the less grumpy I am, the happier I am, right? So more sleep, less grumpiness. There we go. That's a linear relationship between two quantities, right? Okay. So there we go. That is sort of what we're looking at now. In the example we just did, we did some made up data from Instagram where we were looking at the number of followers, and we were saying it kind of made sense that as the number of followers would increase, your likes would increase, right? Because you have more people seeing your pictures and, you know, all of that. So anyways, that turned out to have a very strong linear correlation. Okay, so linear regression, we use data points and we find the line of best fit. Google Sheets can do that for us, obviously. Now let's get into the R-squared value, right? Which is a little bit of a tricky concept here. I'm actually going to escape after I read this right here, which says R-squared times 100% of the variation in Y is explained by the variation in predictor X. Okay, that's a pretty complex sentence. Let's look at it, analyze it, and see if we could break it down. Right here, I got this from New Online Courses Science. Thanks for throwing that up there. Penn State, appreciate that. So let's read it again. R squared times 100% of the variation in Y. Right, so let's look at this, okay, right here. So we have some variation in Y, right? Y increases as X increases. So R times 100% of the variation in Y. So the variation in Y, how much Y is sort of moving, right, either up or down, is explained by the variation in predictor X, right? So in this case, you can see that the data points are very, very close to the line, right? They're close to the line, or they're on the line in many cases. So right here we have an R squared value of 0.97. So we could kind of think of that as like 97.4%. Like as the change in Y is 97.4% explained by the change in X. That is one way to think of it that I found and I thought was good. So anyways, it's kind of hard to understand R squared. If you don't understand that completely, it's okay. It's basically just the closer this number is to 1, the better the linear relationship is, the stronger the linear relationship is, right? Now, I designed this data set. I made it have a very strong linear relationship, right? I knew how to do that. But now we're about to dive in and look at the real stuff, which is the California wildfire data. Okay, so here we are. We're going to look at the real California fire data. I pulled this from CAL FIRE's website. And as far as I could tell, 2016 was the last year of data that they had available. I don't know what's going on there. I'll check periodically and see if I can update it. So we might get some new years as time goes on. I may or may not update the video. Anyways, okay, let's get into it. First thing we're analyzing is the total acreage burnt and the dollar damage of the fire. So the total acreage burnt, you know, that's the size of the fire, how many acres of land were burnt. Dollar damage, that's talking about how much cost to the citizens and government, I believe, of California did that cost, you know, so firefighting efforts, property damage, everything, how much did it cost? So here we go. Let's copy this and let's come over here and let's go to the bottom left and let's create a new sheet. Okay, so we had the old sheet. Now I will do my usual size increase here and then we'll paste the data. There we go. Okay, we've got the total acreage burnt and the dollar damage. Let's highlight this. Highlight this, maybe just, yeah, okay, get that. And we'll go and insert the chart right here. Okay, now I'll move through this a little bit quicker if possible, since we've already done it once. Okay, that looks good. Go over to customize, open the series drawer, put in the trend line, change the trend line color if we so desire. We'll make it a nice green since we're talking about forests and stuff burning up here. Use equation, show R squared. There we go. And we have our dollar damage versus total acreage burnt regression analysis here. Let's do this. Regression. Burnt. Regression. Get rid of that verse. Okay. And total acreage burnt regression. Okay, good. Now, when you look at this chart, you can see that there's one wild outlying year. And that year, I believe, was 2015. And 269,115 acres burnt and over 3 billion in damage was caused. Now, the next highest year was 2016, where we paid 148 million in damages, or not paid, but that much was caused. So this is obviously quite an extreme situation, and you can see that reflected on the graph. So I personally think that maybe we could consider this an outlier. Now, I'm not a statistician. I don't really know, but I think I'm going to go ahead and just delete that there. But I'm going to make sure to mention that in the report that I removed that outlier right there. So now you can see this has more of a linear regression feel, right? We have fewer data points, and since we're now working with real data, and you know, it's less well correlated, right? You can see the R squared value, whereas above it was 97.4%. Now we're at 69.7% or 0.697. So we have a lower, what do we call that? We have a lower R squared value right there. Okay, so that's just something to consider. All right, but we got a job to do, of course. Let's pull this into our chart, and chart from sheets. Grab that linear fire analysis, and now we want dollar damage. Import that. Okay, so there we go. We've got the dollar damage and total acreage burnt regression here. Is there a linear relationship between total fire size and the dollar damage? That is for you to answer. Let me not give my opinion. I almost did. I wanted to, but then I contained it, so I'm getting better at this. Okay, let's look at number 2. Can you develop a linear equation that will roughly predict the dollar damage given the acreage of the fire? I think we did that already. Let me help out with that a little bit. So here we go. We have 402x plus negative 2.29 e plus 0.6. So let's put that in there and then explain what that means. 2.29 e plus 0.6. Okay, so what does this number even mean? How can we translate this and make this equation a little more readable and a little more usable? So first of all, let's come up with some variables. Let's use D for dollar damage. And dollar damage is our dependent variable, right? Total acreage burnt is the one that's kind of driving everything in this case, right? The dollar damage may depend on how much was burnt, not the other way around. Okay, so dollar damage, D equals 402. And now let's come up with let's use A for acreage. And then we have a plus negative, so let's just turn that into a minus. And now we have 2.29. So this is actually using scientific notation. If you're familiar with that, you know we'll need to move the decimal point 6 times to the right since it's positive 0.6. If you're not, then you can just watch here. We're going to go 1, 2, 3, 4, 5, 6. So we moved the decimal point 6 times to the right. Okay, so our equation is dollar damage equals 402A minus 2, let's see, better put some commas in there, $2,290,000. Okay, there we go. How accurate do you think your equation is? You can answer that. If a fire burns 150,000 acres, how much dollar damage do you think it will cause? You can answer that as well. Now we get down here to the last data table, and wow, your opportunity to really just do an insane amount of linear regressions and think about all this stuff. And it's so exciting here. We've got a ton of data here separated by brush, grass, timber, woodland, and other. So we're looking at different fuel sources, and then we also have the total acreage burnt and the dollar damage. So theoretically, since we can do these linear regressions, I mean, in a group, you could split them up and go even faster. Even doing them by yourself, you could probably do one regression in 3-4 minutes, right? Just copy and paste, put in the graph, do all that. It won't take too long. So we could do this 10 times with 5 fuel sources and then the total acreage, and then 5 more times with the different fuel sources and the dollar damage, and you probably will find out some pretty interesting stuff. I think that's all I'm going to give in this video. I'm trying to keep it short. I know it's going to be long, but I think I will end it there. Thank you so much for watching. Good luck with this. Have fun as always.